Okay, welcome to the second build video on the Ender Thrive. This is going to be the Z-axis. There's two ways to put this Z-axis together. One way is the 350 millimeter. That's, the stock Ender 5. Basically, if you had stock lead screws, I didn't measure them. I want to say they're 365 millimeters. They might be 385. I didn't measure them. But if you got stock ones, then the Z goes together one way. And if you got 400 millimeter ones, as long as you don't run stock Ender 5 linear bearings, they're 10 millimeter. The rods, basically you're going to have 4 Z rods that kind of gonna mount on these brackets to the left and the right of the stepper motors on both front and back. The outside one at the front is gonna be outside the frame, kind of like that, and then the one back there will be inside the frame. But how you mount them depends on if you want 350 or 400. But like I said, if you have to buy your leads, they're probably going to come 400 anyway. And what I did when I built this is a stock linear bearing. It's quite a bit longer than the ones that I used. And I did this for a couple reasons. One is, if you're running dual Z, you really don't need this long of a bearing for the extra support. It was cheaper, and I noticed that I could get 50 more millimeters of height in the same frame, so the 50 millimeters was worth it to me. So this is a 3-piece printed slidable jig. Basically, when I put it together, I tightened up 2 holes, 2 bolts. Left these ones a little loose because we're gonna put the bearings in these holes and your brass nut in the holes when we mount everything up. And we're going to use it as kind of a jig to get everything, left and right from the centered stepper. And so anyways, I got these out because this is an important thing. So right here, this is a coupler. They're not any good for the Z because, as you can see, I'm not really squeezing. I'm putting a little pressure, but not real bad, and that's shrinking. And you don't want that. So I highly recommend this type, which comes factory on an Ender 3. One of them is going to have a 5 millimeter hole on one end and an 8 on the other, and the other one is going to be 8 millimeters straight through. And it's because so it's because of this stepper block. Basically it's belted dual Z. Once it's aligned, you don't got to mess with it. And it uses 2 of these 608 2RS bearings, just 2 of them, and they press into this block right here, and some M3 threaded heat inserts go in them. The length of the bolts to hold them on depends on which way the Z goes, but I'll kind of show the stock way first with the Ender 3 assembly. I probably won't go all the way to full assemble that but I'll assemble it enough so you guys know which way they go, and there won't be any question about how it works or anything. And then I'm gonna do the 400 style and finish it off. One thing that I was hoping would get done before the video is over is my new Z belt tensioner, so I may have to like finish everything but the belt tensioner, and then like add a few minute video linked onto this one at the end with assembling that. And hopefully I don't have to tweak it any. But so all these parts bolt on with the 8 of these bolt on with M3 by 8s with T-nuts, and it's 2, 4, 6, 8. So there's 16 M3 T-nuts and M3 by 8 bolts. Doesn't really matter what style heads as long as you can tighten them. And then this, you get 2 steppers on your Ender 3 for X and Y. This is the Y stepper motor, and I use the Y stepper motor on the Z simply because it's got a longer shaft than the Z motor does, and I didn't feel like switching out the shaft on this one. I mean, I do have jigs in the file set so that you can pop one of these motors apart, push the shaft out either with a punch and a hammer or a press, or there's multiple different ways to do it, and I'll actually make a video on that too, because you're gonna need to convert or buy a dual shaft NEMA 17 for the Y axis unless you go Core XY. And so I'll be showing a little video on how to swap out the shaft. Doesn't really take that long. Basically, you just need to take the motor apart and then use the little jigs to push it apart. And I put a little super glue on the shaft, the hole that the shaft goes into before I press it together. But that'll be another video anyway. So these stepper motors are gonna mount with, let me see, I got the bag over here. If you do it the stock way, they're gonna be M3 by 8, and the other way, I'll have to measure those in a few minutes after I put my camera in the mount. And then, so I'm gonna pause the video, set up my camera, and we'll get this show on the road. Okay, and we're back. So, I guess I'll show the stock way first. So the stepper here. So if you've got a stock stepper from a Y or an X, it'll have a pulley on it like that. It'll technically be flush with the top of the shaft. And this one's pushed down a little further than you would for the 350. The 400, you push it down until it almost rubs the top of the motor, but not quite. And on the 350 size, which is if you get stock Ender Z rods, basically your motor is going to go on the back, and you're going to want to point your plug towards the left of the machine. And as you can see, this is below the surface. When you push this on, you want it to technically be so that it'd be the bottom lip, but down here you want to be kind of flush with the top of that, or anything close. And also, I guess I had to have for the regular 350 and extruder shaft, but I'm going to show how to swap out a shaft if you don't have a long enough shaft. But that'll be in a little short video after this video. So anyways, let me grab what I need here. Oh, did I? Oh, right here. We're going to use this one because I set it up as the example. So I started my M3 by, I think I said 8. Yes, M3 by 8s. So we're going to put the motor in like that. Going to get every screw started. And you don't want to crank them real tight because it's aluminum and plastic, and that's why I didn't tighten up over there. But it is possible to strip these screws, so what I do is I go till everything bottoms, and then I just kind of go a little more. So that's what the rear one's gonna look like, but obviously your stock Z, call it M5 on one side, 8 on the other, is gonna drop on here, and you just tighten it up. And keep in mind that pulley will be up a little bit more, not a lot more. And then there's 5 bolts that hold it on, and they're M5 by 8s, and with T-nuts on the back. And the idea is we're gonna mount it. I don't know, hopefully you can see that. I guess I'm going to take a peek in the video. Just make sure. Okay, yeah. So, that's going to mount like that for the stock height. And then we're going to have the same thing for the stepper. These are those bearings I mentioned earlier, the 608R, 608 2RS. What I did to put them in was I just took an old bolt that I had, an 8mm bolt, shoved it through the hole, stuck some washers on, took a nut, threaded it together, and it just pulled my bearings in. And of course it'll firm up when they bottom out, and you just want to back off and take them out. And then I just took another, you can use a 5/16 or an 8mm. I didn't check the specs to see which one's closer, but basically you're going to push your heat inserts in there, M3 heat inserts. And then on the opposite side, this sawed off bolt, which I did with a hacksaw, and I also just took a file. I don't know if you can see it, but I just took the bird edge off. It doesn't have to look perfect, but you just kind of run your fingers around it, and if they catch, you want to file a little bit more, and that's just so that everything rides kind of true when it's together. So this bolt, this is the bottom side, it's going to go through. And then a washer, like a stamped washer, you can use 5/16 or 3/8. I'm 8mm, excuse me. So 5/16 or 8mm. But you might not be able to see it in a video, but the way they stamp these, you have a rounded edge and then you have a more kind of aggressive edge on one side. And it's going to go on so that that rounded edge, which is this side here, goes towards the bearing so that there's no binding. And then on the 350Z, that'll go on, and basically you want to just kind of push up on the bolt, kind of hold it like this and give it a tighten. Let me see if I got, I think it's this one. It's probably the one thing that I didn't dig out in this video. Never usually use these ones that come with my Ender 3 flats, but it's closer to me. So basically, there's 2 set screws. Just gonna tighten them up, and then you want to give this a little turn, just to make sure that it's not like the washer's not rubbing, and you know that it turns pretty freely. And then we're gonna take, where did I put that? Not that one. Oh, I just had it. I suppose I can dig another one out. Oh, coupler. So we got our Z coupler. This is not a stock Ender 3 one. The difference is it's 8mm straight through. If you happen to have a bunch of these in 5mm on one end and 8 on the other, you could probably get away with running a drill bit straight through it without these tightened up, but I wouldn't guarantee it, so you're probably better off, especially if you're not good with like drilling stuff and getting it just right, to just buy one of these. And this is going to drop on. It's going to tighten up. So basically, now we got that with the heat inserts. And we're going to use the same M3 by 8s to mount that. And that'll mount the same way here. And if you'll take notice, like, see how it's, this is right side up. The other type of Z that I do, this is flipped, but, and then there's a spacer, but see how you get the height there. Basically, I mean, if you're not perfect between both, as long as you're like really close, it's not going to affect it, because it's like 400-ish millimeters across, and it's not really going to make a difference if it's like a 1/4 millimeter from the stepper motor. But so, and then before we get to the mounting part, what I did, keep in mind I'm in the United States, so this doesn't have to be totally perfect. It can be plus a millimeter, minus a millimeter. But the idea is you want your stepper or your bed in the end to be centered in your frame. So you got a 406 millimeter, which is 16 inches. And so what I did was I took my tape measure and I divided that in half at 8. And I just took a piece of masking tape, stuck it on the back side, just barely wrapped it up over the edge. Measured out my 8 inches, or I guess it's 203 millimeters. Like I said, you could be plus or minus a millimeter, isn't going to matter. But what does matter is whatever it is on the front, you want it to be that on the back. And the reason why is because if you're 2 millimeters one way on one, or 1 millimeter one way on one, or 1 millimeter one way on the other, well, now your bed is tilted in that plane by 2 millimeters, and you're not going to maximize your bed, because I literally sometimes print 235 millimeter prints, and my bed has got to be dead not to do it. So anyways, I put a mark here on the tape, and I did the same on the back side. And then I'm going to pull the camera down for a minute, because I'm going to show you what I did here, because obviously you can't have all these screws, the mounting screws, in and get this into place. So I got one T-nut there. Basically, this will be bolted together. I probably will bolt it together in a minute, but I just kind of line it up, got them close. The idea is we're going to push that tight. And we're going to drop, snug up 2 of these, centered. And that's going to be the permanent location for these centered. The back's going to be done the same way. And you'll drop the screw down through the mount and catch the T-nut, snub them up. And then you can pretty much tighten those, because they're not going to go, you're not going to move those left and right. You want them centered. And then after that will come one mount on each side like that, and it'll be both on front and back. And again, the front mount sticks out of the frame, the rear mount comes into the frame. And in fact, I'll probably set this up the other way and then assemble, just because then I don't have to backtrack a lot. But so that basically gives you the idea there. And I'll also explain the belt tensioner when we get to that step, because going this way, the pulleys are going to be up just above these rails, but over in here somewhere. And that's 1,000 millimeter GT2 6 millimeter belt, loop belt. And obviously the XL 400 version has a longer belt. I'd have to look that up in my notes to know what it is. But so I'm gonna pause the video again and then set up for the other style Z, just so I can show it to this point, for the 400 millimeter. And I highly recommend, if you don't have Z rods, just doing the 400 millimeter, because when you buy them, you're like a stock one, I believe is $365. It might be $385. I can't remember for sure. I don't actually have a stock Ender 3 one to measure. But these ones are 400. And I probably already showed this, but this is a stock bearing. This is not. They're substantially shorter. I haven't had a problem with it. You have to run these long ones if you run single Z. And I don't run single Z just because sometimes you get a little bed sag and you don't want that. And so there is 2 extra parts. I think it's 2 extra parts for the extended height to 400. And one's going to go with that set. and one's gonna go with this set. And I'm gonna pause the video for a minute. This is gonna be the longest video because it's the biggest, hardest part, and I might even split it into two, so it's the x-axis and then the bed, just to keep it a little bit shorter. So be right back in a few minutes here. Okay, and we are back, and now I'm gonna show you the other style, the 400 height. Same frame. Like I said, it's critical to have those short bearings that I just showed. And these are still the 420 millimeter. They're just a 10 millimeter smooth rod or a linear rod. I think you kind of just pay for more for a linear rod than a smooth rod, but they're pretty much the same thing. So this is the rear mount, and I'll have to flip my frame over and put the T's in it to do it. But so well, anyways, we have our motor, and the height of, I'll make sure it's in focus, the height of this stock pulley is pretty much so it's not quite touching the top of the motor, just enough clearance so it doesn't have friction. And then we got a new part, this right here. It's a spacer. It's 15 millimeters thick. And so this spacer, it's much easier to start the bolts, which are going to be 3M3 by 20s. And as you can see, it'll line up here, and it'll have an open spot over here. I'm probably going to make a bushing and put it in the file kit on the group page. That's 15 millimeters thick, just so you can put the extra bolt. It's technically not needed. Vorons run with just 3 bolts in their X and Y steppers all the time. And I think the Mercury 1.1. So basically, I'm running my bolts down through. And there's going to be, because keep in mind now this is the top because we're going taller. And so we're going to put 2 on what'll be the right side, because our belt tensioner is going to be over here. I mean, I guess technically you could run the belt tensioner over there if you wanted to, and then you just reverse it. I haven't done this. In theory, it would be because you're centered with the steppers. It should just work. And then the third bolt is going to go in the back. And they do slide on, but when you have 3 of them, sometimes it's easier to just twist them in a little bit, because you get them cocked a little and they'll bind pushing in anyway. And so the stepper, I'll have to show all the things that are different here. And I'll show flipping the frame, and I'll actually bolt them on this time. If you want, and I probably will anyways, because I got colored extrusions coming, and I'm going to build another one of these totally from scratch. Like, cutting all the extrusions on video. The videos might be a little bit longer. I'll probably leave these videos up for people that just want the short version and don't really need all that extras to watch and take up your time. But so anyways, the idea is this stepper, the belt's got to clear the underside now, and it's going to run under the frame instead of above. And this gives us a little more clearance to drop the Z a little more. And like I said, 400 millimeter lead screws are required. I always kind of go in somewhat evenly with these, and you don't have to go real tight. Obviously, you want to go tight enough so that they're not going to like back off, but you don't want to strip them either. And so far we've got this, and this is going to mount on that back bar down underneath. That's why these legs are taller. Oh, how stupid of me. I'm supposed to put the belt in there before mounting the stepper together, and I bet you I can't get it in there. So, well, I guess I'm glad I made this mistake, because I would have never thought to tell you guys. But, well, actually, I probably would have, but so the belt's got to go in before it can go together, because you're never going to get it around that. And so what I do is I just kind of drape the belt around the pulley. Again, you want the plug headed towards your electronics. And then we'll just tighten these back up again. I can't believe I like set this up, and I like know it goes that way, but I guess I'm like trying to make a video as quickly as I can. Like some things are slipping my mind. So that's that Z, and so that's the coupler with the 5 millimeter and the 8 millimeter hole. That's just gonna drop on there, and this one, and we're gonna tighten that up, make sure it's on there fairly solid. And I'm just going to set that there for a minute. It's going to mount like that up on the frame, centered with that dot, but I'll have to remark that. And obviously, gravity is going to fight against me with the holes that with the T-nuts. So when I flip it, I'm flipping it so that gravity doesn't fight me. But before I flip it, we're going to put together the fake stepper block. Again, remember how I used to bolt? I had a bunch of washers and a nut. I snubbed them up. You kind of want to watch them at first because they can go crooked. And if they go crooked, you kind of want to help it a little bit just to get it started somewhat straight. And then this is the bottom. That's where the heat inserts go, the M3 heat inserts. So I cut this off. Originally I did it at 45. 45 works. I think it was 45. Let me double check. so yeah, so I cut them off at 45. Probably 48 would be more ideal. It's not the end of the world if you cut it at 45, but so bolt's gonna go through the bottom, and so and then again we got the same washer, and this washer has the curved part and then the more sharp edge away from the bearing, and just drop it on. And then we're gonna need our 20 tooth, and that's, in fact, I better say this right away. Whatever you have for teeth on your stepper, you have to match on this fake stepper, and I don't like playing with these steps, so I just went with steps and figuring out if I use a 16 what it would figure out too. So I just went with the stock 20 tooth. So we're gonna put our thumb on the bolt and gonna kind of hold it down. You don't want to squeeze this real hard, but you don't want to have like up and down slop when it's tight. So, and again, I should have dug out that tool. So there's 2 set screws. We're gonna tighten them up, just like we did before. And then we want to check, make sure we got no rubbing, and that we got no up and down play. And after that, I guess we'll wait. We'll wait on putting that on until we put the... So we got a spacer again, and I'm gonna, where this one is gonna mount this way on the front, we're gonna have it kind of, that's the back side, it's gonna sit kind of like that. And you want the opening to go the way the belt's gonna be. And we got the M3 by 20s. And we're gonna put those down through. And not forget to put the belt in the slot this time. Basically, I'm building these, and then I'm gonna flip the machine and center up my steppers. And also, there is an advantage with using aftermarket Ender 5 aftermarket Ender 5 lead screws. They have a different amount of starts on the threads, and that's why on an Ender 5 the Z steps are doubled to 800 instead of 400 for base starting settings. And one of the advantages to that is if you get like a bunch of weight on your bed, the Ender 3 ones can drop. It's not saying they will. Like at the end of a print, it could slowly go down. Now, if it was on an Ender 3, that would matter, and the reason why it happens on an Ender 5 or Ken is because you get a little bit more weight than you do with that other gantry. But there is a fix for that too, and I accidentally ordered the wrong size, so I got a whole mess load of Ender 3 ones that I'll never ever use. So basically, it's not what they're made for, but it works. So this one just basically, it's 3 pieces. You get a spring, you get your nut, and then a piece there. And what it is an anti-backlash lead nut. And if you put it in, and you put it in upside down, so that the spring is on the upside, it'll just kind of give a little bit of friction. Not enough to really notice it turning the rod, but it's enough so that it'll stop that from dropping. And if you have noisy leads, it doesn't matter which way this turns, because it's going to go in there like that, but remember the bell. So basically, you want to make sure there's no twists in this belt. And you're going to, again, drop it around the pulley and get it the right way here. And you're going to make sure that, it's in the opening that the belt's going to run in. And I'm going to start them all. Goes. Good deal. And now we go. And a lot of this is plastic. You don't want to crank on it so hard you break the plastic. You don't want to. The heat sinks aren't going to pull out because they can't pull through the top. And so basically, we'd be flipping the frame. Now it's going to differ in looks. This is going to be mounted like this now, instead of, right side up. This is going to be on it. I think this is the right size. Yeah, and if you use an American, I guess you get it snuffed out fairly good. It works just fine. So, and like I said, there's bolts that go up through, but gravity is going to work against us with these T-nuts. So we're going to have to flip the frame in order to do the 400Z. So we don't want to lose these T-nuts because I'm going to need them. In fact, maybe I'll pause the video while I'm flipping the frame just to kind of shorten it up by even minutes is probably a good thing. Alright, so be right back when I'm set up. Okay, and we're back. My under is upside down. I did have to redo my tape with the little dot. You don't want that very far over this because after we get it in position, we're going to lift and pull. But so it's 206 millimeters to the center. If you went with standard length that I did on this, you can technically, it's a tiny bit oversized for what it has to be, but it's because if you want to run a big hot end. So basically I measured from not this extrusion, but where this one begins over in half the length to the center. Just put a tape dot. Like I said, whatever you do here, you got to do on the back. If you're 1 millimeter off in a certain way, it's no big deal as long as it's the same on the back. Obviously, like 10 or 20 millimeters would be a big problem, because then your bed's way off center, and maybe with a stock hot end it might still work, but it won't with anything oversized. So I already dropped them in the back, but what I do is I got a M5 T-nut. They're kind of small, you know what they look like anyway. And then I got me just an Allen wrench that'll fit through this hole, and the side that's going to be towards the pot, I just kind of slip it through the hole, and this is just going to guide me into this slot, so I don't have to mess around and flip it over a dozen times before it lands straight. And that one's going to line up in the center with that dot. And then we're going to do the same thing with the other two, one to the left and right of it. Just get them in there for now, because you're going to use one of your mounts just to kind of, stepper mounts, just to kind of get them basically lined up. And I had printed an extra one so that I didn't have to take as much apart for the video, so I'm just going to eyeball them as close as we can get them. I've already done it to the back. And so that looks good. Figure out which is it that one? What's this one? So, and then where we're upside down, you're going to find that this belt will kind of not really necessarily hinder you, but so, and what I'm going to do is I'm going to line that dot up as close as I can with the naked eye to that center hole, and I'm just going to lightly snub these for the moment. I never crank anything all the way down until I have everything started. And so basically this hole right here is going to line up with that dot. Once you're satisfied with that, I guess pull the tape so you can still get it out, because if you crank these down, you're going to leave a piece in there. And just as a lot of times, if you're off a little bit, just take an Allen wrench, you know, and stick it in and kind of line it up. Mine are actually looking pretty good, so, and I just push them down in. And sometimes you got to give them a little tiny wiggle to get them to catch that T-nut. And then you're going to get them all started and just kind of barely snub, just so that you're not like tilting anything, binding something, making it harder for a knot. So I got all three snubbed. We're centered. You can go ahead, tighten them. Remember, it's plastic mounts, so I wouldn't like go cranking them real crazy. And so this is the front and the fake stepper motor, because I just basically lifted it up, direct flipped it. So we're going to do the same thing with the real stepper motor. So you want to make sure your belts aren't twisted, and so you're going to line up with that dot again, and you may find it easier to turn the machine around. I'm going to just, because I got a pretty solid base, I'm just going to tip it up a little bit, make sure I'm where I want to be, tip back down, and we're going to snub the same 2 bolts again. 1 and 2, and then let's see. Go ahead and misplace 1 bolts again. I don't know how I keep doing that. So my nuts were pretty lined up. I've done this a few times with different machines. There's one of them. I'll put that on the other side. And just snub them down. Oh, I slipped out of the slot on one of them. Well, that'll probably actually be somewhat helpful for showing you what to do if that happens. I mean, if it goes inward, you kind of have to lift the bracket back up because you can't really get to it. But let's see. Probably not going to find that screw. I think I got a few more over here. I got a brand new bag somewhere, but I had it just before this video. You know how that goes. I might actually have to find it. Oh, there's one. Okay. So I'm going to pull the camera down because that way you can see. So I wasn't quite lined up with this one and it slipped and popped out. And I'm a little short for this bench. So I'm going to push it in so I can just see it. Of course, if it was spun around, I'd be able to see it a little better. So if you push it in too far, you'll have to pull the mount off. I might have to, I'm not sure. Or actually, I guess if you push it in too far, you can just kind of tip the frame. Oops, I slid underneath my bracket there. And so, in fact, this will help guide us a little bit. Obviously, it's sticking out a little. So, let's go in a little bit. I'm going to set the camera down just for a second and spin the frame 180 so it's closer to me. And it's probably better that everybody does that because then you can just kind of see what's going on a little better. So, anyways, I used my little tool, I pushed it in. I don't know if you'll be able to see the silver threads there. So that's how I dealt with that if I had an issue. Let's try to get rid of this tape. I might have actually snubbed it in there, but I guess if I loosen that just a hair, should be able to pull that tape right out. And of course I wasn't square cut. It's better to be square cut, but as long as the dot's in the right place, it'll serve its purpose. So we're centered where we want to be, so we can tighten these up. I don't do the Z belt until the end of setting up the Z, because you're going to be moving the rods up and down, and it's easier to adjust the gantry and the linear rods without the belt on. So I'm just snubbing these up, getting them tight like how you would if you run it. You don't want to crack the plastic. So that's the two-stepper motors and both styles of the Z. As you can see, like in the end, this belt would have an adjuster. It's going to have two pulleys, kind of like that on the print that I did, or I'm doing, I should say. And so I'm going to pause the video, flip this thing back over so that this Z motor's back in the back like it's supposed to be, and we're upright. And then we'll start mounting these, and we'll be using this, but there'll be a little bit more prep work because we need these 4 bearings, and obviously you haven't built yours yet, so those won't be bolted in. But I'm gonna yank these. This was made out of a piece of scrap metal just kind of found in the back of a junk van, and I hadn't invented this yet or modified these pieces to actually do it, so I did mine a little bit different way. But then I realized that we needed an easy way so that, like I said, if for some reason these front to back rods are plus or minus a blade's width, then it doesn't matter because you're not going by a measurement that somebody gives you. You're actually going to use this to get spot on with, this. And like I got 10 of these. Obviously one of them's going on a demo, and so I can pre-machine them, but if I pre-machine them, they got to at least come with the front to back 4 2020s. The other ones, left to right, don't matter as much because, like I said, as long as the left to rights are the same on top and bottom, you're good. And as long as the front to backs are the same on all 4, you're good. And so, like, you could be technically, like, if you wanted more travel, you could lengthen the left to rights if you want to travel on X for like some kind of, I don't know, maybe a Hermit the Crab or something. But I think this has enough room for that the way it is. A regular Ender 5 does not, because the front and the back, top and bottom, are only 370 millimeters, and it's just barely enough for a stock hot end to get the full 235 with a BL Touch. And I'm not sure about with the CR Touch because they're a little bit fatter and I've never used one. And then, of course, the Ender 5, what I don't like about that is you got to get your end stops perfect to get the full 235. And like if you're a 1/4 of a millimeter off, the stock hot end will hit your front bar, and it's like So this is slightly tweaked from an Ender 5 intentionally to get rid of some of them issues. But enough of the babbling. I'm going to pause the video, set up for the next part, and we'll get this finished as fast as possible. Okay, and we're back. I did a few things off camera just because it was time consuming and I can pretty well describe what I did. So this is assembled. These 2 bolts here, let me make sure you can see where my thumbs are tight, nice and tight. These ones are loose. so we get some slide. And then I left all these bearings just a little bit loose. I used M3 bolts. I think M3 by 8 is what I did for final assembly. M3 by 8 will work, but the basic idea is during final assembly, you don't want a bolt that's longer than this bearing, and you don't really need them as long as what that is. Final assembly, I just kind of had mine like that, but this is just the jig anyway. So what I did was, so I just set these on because they're in the back. It's going to be harder for you to see what I'm doing. Back and front is the same. So I left everything loose so it wiggles a little bit, and I just kind of rested this kind of near my stepper motor. Started all, slip these in, snubbed them. They can move left and right still, both top and bottom. And then, so I'm going to do the same thing I did in the back off camera. And we're going to leave them so that they can still slide, because we're going to need to adjust them. Otherwise, you're going to have bind. And bind is something we outright do not want. So I find sometimes it's easier to tighten until you see it move, and then tilt in a little, and then you may have to back them off just a tiny bit or something to get them to still slide. You don't want them to move so easy that it's not funny, but you don't want to have to fight them for this step either. And so there's going to be 2 on the bottom. The gap's not real big. I'm going to say it's under 10 millimeter. I don't know the metric scale that well, but for now we're just putting them so that they slide. We're going to eyeball them a little bit with that jig after we tip it up, just to kind of get a basic idea if we're close or not. And this jig is critical for making sure that the holes are in the right place. On the tops for now, I just kind of put them up there, eyeball them. They're probably not even going to be close at first. I mean, they'll be close, but oh, and I did. So I didn't have that one backed out enough. But not because it didn't catch one yet. Every once in a while, one of those gets to be a little fun catching. Just till she slides. Make sure it's still moving. Yep. And same thing with the last one. There's no real up and down to these. Well, I mean, they work either way anyway. The final design, I guess if you flip them any which way, there's like a little nut that goes in on the final design. I printed half of them that way on this one because I wanted to test them. It's this in. Sometimes okay, so they can all slide. So what we're gonna do next, we're gonna take this here unit. We're just gonna kind of set it above everything. We're gonna scooch down. You won't be able to get this exact, but what you want to do is just kind of eyeball that for straightness, eyeball this for straightness. And we're going to take our lead screws, because this will help center us a little bit. Whoops, other side of the frame. This is the 400s. We're going to thread them down in so that they protrude out. We're going to make sure, well, make sure you can see. So these outer brackets that I put on, what we want to do is thread that lead in until she's just about lifting it, but not quite. And so I'm a little past. So I went quite a bit past. So they're going to be resting there. You're going to do the same thing with the back one. You may have to slide that join in and out some to get it started, depending on how loose you left them as to how easily that will move. And so I got to slide mine quite a bit. I might have to loosen one of them. Okay. So and then we're still not going to tighten those because we're going to need these in. And what I usually do is I just slide these over so they're not in the way. And I slide and twist. And I slide it down below so I can slide these back over and get them in. But we're going to put all four in, and like I said, you may have to slide the bottom ones just a little bit, because you know where this is centered and we just kind of eyeball that, they're not going to be dead nut. So slide these two out of the way. And this will help kind of center everything. You may even have to lift up a little bit, get these started. It's no big deal if your lead pops out. Like I said, we do not want that tight yet, because one, it's going to come all back apart. And this is just kind of to get the bottom lined up. And let me see, the last one's right here. I had that one pretty close. So we'll just slide them in eyeball close for now. And let's see, probably the easiest way to do this is to slide one up. It's not going to quite start it yet. What did I do with... Yeah. So, what we want to do initially, maybe I'll grab the phone so I can kind of show you. Let's bring that one up close too. Okay, if I can get it off here. So we kind of want, we still got everything floating just a little bit. What we want to do So we want to make sure that left to right, we're not like pinched a little bit, and they feel like obviously the middle is gonna kind of be stiff a little bit because of this lead. And so when we think we're right, and I think I have to go a little bit that way, but we'll know for sure in a minute. So what I'm gonna do, and I'm not sure, I mean, it'll be at a slight angle. This is kind of just to get you close. The final adjustment is going to be when you tighten, or when you snub everything and you're going to move the bed up and down without the leads. But right now, we're mostly concerned with just getting these bottoms where we want them. The gap's going to be the same there between the two orange pieces as there, and you want these to be kind of square, and you may have to let go of the square a few times, you know, like hook it in at the top. It's easier to kind of line it up and give it a twist. And you know, your lead screw, you want to be, you don't want it leaning, so I'll shift it a little bit. With the square, I'll have to put the phone down or the camera to do it, but I'll probably just put it back in the mounts. And so that's the basic overview. And when you do the back and the front, after you do both, it would be a real good idea to kind of just double check the feel of everything. So what I'm going to do now, I'm going to twist, bring those up till they're flush. And I think one of these got printed on different machines, a little bit snubbed, but usually I can just get them to go. And then I'll have my screwdriver over here. I think I can use this. I don't want to cut my hand. Okay. Alright, I guess I'm going to pause the video, grab a couple things that I need. Probably need some slider. Alright, so be back in a minute. Okay, and we're back. I slid that bracket in. Basically, I guess didn't really take much, but so one thing that I do want to do, kind of as a double check. So we had 203 millimeters or 8 inches to the center. Let me see if I can get my tape in here. And I guess so. I just kind of want to eyeball it a little bit here. Okay, it's going to stick out a little far for measuring it that way. So basically, you don't have a really huge flat area here, but you got to make sure you're pretty square. So as we slide stuff, this lead screw will lean one way or the other. And you just kind of want to get it as close as you can to true and straight. They're made to float a little bit, and then we kind of, you can kind of, if you hold it right, you can get on both bearings and kind of judge if you're square or not. And once you kind of get square left to right with both of these, so that you know you got no bind, I'm pretty close there. Always double check everything. And so my bearings feel decent here. Probably gonna tweak just a little bit with the back. That one's gonna come that way. And it's a good idea to spin it around. Because like I said, you want everything kind of straight and true before you tighten anything. So I'm going to spin the printer just because it's easier to work on something that you can reach. And so now we're on the inside. I believe this will actually be easier to square this side, but I could be wrong. I guess about the same. So the bottoms, I guess let's, okay, I don't feel any bind there. Well, other than the lead that's holding me. So gotta tweak that one just a hair. Yeah. Yeah, that's pretty decent. So, and what we're gonna do is I didn't use lock nuts here on these 4 bearings. Probably only really got to tighten 2 bolts on each one, but crisscrossed. What I like to do is turn them till they're nice and straight. You don't gotta get them excessively tight. You just gotta get them so that they're not floating around. And of course my under 3 set didn't come with a wrench to hold them, but I guess I'm getting lucky and they're kind of biting. These don't have to be hugely tight in this step. I mean, you will want to tighten them up a little more than I'm doing now on the actual build plate. And the reason why we're tightening these now is because they're going to be centered on the shaft down bottom here. And if they float when we pull out this lead and kind of test the up and down travel, just to kind of get an idea if we're going to have much bind. We don't want them floating because we won't feel any of the bind we would have had. And this kind of also just ensures that when you tighten these 2 bolts that you're kind of where you want to be. And I'm not going to bother to spin the printer again to tighten these, because I'm just kind of, you saw me do the front ones, or not sure which way I have this printer turned. I guess it's backwards. They don't have to be overly tight, you just don't want them floating. Just kind of putting a finger on the knot, getting it, you know, a little more than hand tight. Probably should have just done one of these and paused the video because it's pretty long. Like, you know, if you want to get more fussy and make sure nothing moves, you can put a wrench on them. But so I'm pretty happy with how my bottoms are. So it's gonna be a little bit tricky to get your hand in there, but what I'm gonna do is just snug the outer screw on that bottom Z-bar bracket on both sides, just so that those don't move around on the bottom. Spin it back around so it's easier to get to this side. I'm going to leave one screw in each, just slightly loose for now. We just don't want them sliding around as we, so I'm going to pull my Z's out because we don't want it flexing this plate, my leads. So we just kind of, and you know, with no lube, you will probably feel a little bit of a bounce, but you just kind of want to make sure after you've leveled them that they're not pinching in on these. And as long as they're not pinching in on those. And another thing I do like to do is from the outside of the printer to the outside of this bracket, I like to check the top and bottom just to kind of see if the measurement is, you know, the same or very, very close. And so basically, let me see. We got it. And they're looking pretty good here. This is kind of like another check, but you always want to make sure it's good and free. And, you know, if all your measurements are matching up, obviously they should, because you're square and you're not getting a bunch of bind, you can go ahead and tighten these brackets and tighten all of them. And then minus the belt and, of course, the bed gantry, the Z is pretty much complete. Oops. Tighten these up. And again, you don't want to break the plastic. So, tight enough so they don't move, and then, oh, that's right. I had, before I changed the design a little bit, because I wanted a fancy nut that inserted into these, I printed some that took M5 bolts, and it was mostly because I ran out of the, I guess it's M4 by 8s, and these are going to get swapped out so that they're all the same. I mean, dimensionally they're all the same anyway. And I don't think I did the back ones, all of them. Maybe I did, no. Oh yeah, plus I'll have to check my measurements there, but maybe I better do that now. So anyways, I'm going to pause the video, check the measurements like I did on the other side, and then we'll be back for the next step, which will be tightening these two screws really good. You don't want it to slide. And then we're going to slide these back down, pop it out, pull the bearings and the lead screw things, and then we're going to clamp it down to our bed gantry. And this is aluminum. It's just got a coating on it. It's anti-scratch. And you're going to leave that on when you do it, because you're going to get shavings. Again, some of them might go underneath a little bit when you drill, and that could scratch the bottom side. I mean, I'm going to do a separate video on buffing this thing so it's like shining like silver pretty much. And it's not a required thing, it just kind of makes it pop a little bit, makes it look real nice, the area that you can see. And like, imagine this with either purple or red extrusions and a nice buffed aluminum finish on the area you can see of the gantry. Alright, enough talking. I'm gonna pause the video. Okay, we're back. I've tightened all of these. I haven't tightened these yet, because basically after everything's tight, I just kind of like there's a little catch there, but that's kind of, they will a little bit before they're lubed and before they're broken in. And this hasn't been lubed, but you don't want like an abrupt catch. Basically it's just dry, so it's pretty smooth. And linear rods, they're kind of inferior to, do I have one open? Probably not. Well, anyways, got a bunch of linear rails, some huge ones, because I'm about to do a 1,000mm build. It's like a $500,000 printer. Well, depends on how you put it together, but to buy one. So this is a linear rail. They come in all kinds of different lengths, but in this case, the way this design is, you can't really use them. There is a way to use them on the Z, but it would be like triple Z, like a Voron, which I have another one that does have triple Z, 2-steppers here, 1-stepper back here, and it'll self-level, no bed knobs at all. I did show it a little bit, you know, in some videos in the group. So, oh yeah, we gotta tighten those. So I used M5s down here. Doesn't really matter. The shorter, I guess, the better, because you don't really want them sticking way out when we align this plate, and we're actually probably gonna do one end of it. I'll figure it out as we go. There's my black screwdriver. Oh, I guess I'm using the Ender 5 tool, because, or Ender 3 tool. So I'm not sure where I put it. So we're gonna try to be steady for the most part. And we're just going to tighten them up. We're also going to double check the other ones we did. And then after we're done tightening, we're going to go up and down again, make sure we haven't had any sudden changes, because sudden changes mean we've shifted something. And that's kind of the last thing we want to do when we're getting ready to drill a plate that you can't undrill and start over again. And so I don't feel any awkward forces. So we're good there. We're gonna take a little twist down. We need enough gap to slide this up and out. I just leave them in there after I get them to this point, and just, you know, slide them down. And then we're gonna lift this up and out. And what was that? Oh, that's just the bolt that was, oh, really? How the heck did that happen? I guess I'm gonna be redoing that step, because for some reason I thought I had my nut on there, and I guess I didn't. But the next part will be, you know, pulling these bearings and everything, placing this on here. We're gonna draw everything out on it. We're gonna draw crosshairs, center punch, the whole 9 yards, but I don't know why I had a nut pull out. It'll probably be okay, because it made an indenture there. But, you know, I don't want to waste a plate, so I am going to double check it. A little bit of a pain, but better to double check than to waste something. And I'll probably just start another video on drilling the plate. It'll be a short video, well, somewhat short. But this one's pretty long, and when they get real long, they're not fun to upload. So video 3, I am gonna do it tonight. Oh, it's probably like 11 o'clock right now, but you know, I got a babysitter tonight, and so I don't have to necessarily get up first thing in the morning. And kind of want to be running this printer by tomorrow night, so, because I do have that Ender 5 right there that's extended, just height-wise, but this beats the pants off that thing. And even though that one is more modified, and it's mostly because I learned a lot more since I did the firmware on that one, and I'm running input shaping over here, and I'm running triple the speed that I can run on that stock. And well, it's not stock, but the frame, other than the Z height, is stock. And even when it was stock, I can still go faster with this one, but a lot of that's to do with Marlin's input shaping. Clipper's much better with their input shaping, but Marlin doesn't do too bad. And so video 3 will be coming up shortly. It's going to be the gantry build. And apologize for the length of this video. Alright.